Here's the next question, number 30. An unbalanced DC Wheatstone bridge is shown in the figure. At what value of P will the magnitude of V0 be maximum? So we have our options given to us, root of 1 plus x, 1 plus x, 1 by root 1 plus x, and root of 1 minus x. So to solve this, let's first redraw the Wheatstone bridge given to us. We can redraw it in the form of an equivalent circuit, like so, please see. So I can draw this as, we have here PR and PR, these two resistances here, PR and PR. And here are the terminals for V0. So this is plus and this is minus. And then we have resistance R over here, and this is the variable resistance R into 1 plus X. And the terminals at these two ends, here we have plus and minus, that corresponds to the battery given here as E. Okay, so the question tells us that we need to find out the value of P such that the magnitude of V0 is maximum. So in order to do that, let's first write down the expression for V0 using the resistances given to us. So let's use the concept of voltage division and write down the value for V0. So V0 in terms of all the four resistances, let's take one side first and write down. So we have V0 is equal to, on this end it would be R into 1 plus X divided by sum of both. So that's PR plus R into 1 plus X minus, now this side. So this side would be written as R divided by sum of both R plus PR, and all of it multiplied by the voltage V, E. Now let's open up the brackets within here and resolve the fractions. So we'll write it in the form of one big equation for V0. I'll rewrite that equation here. So we have V0 is equal to R into 1 plus X divided by PR plus R into 1 plus X minus R divided by R plus PR into E. Now let's resolve the fractions. We get V0 is equal to, okay, here R is common, so R can be cancelled out. In this part here as well, R can be cancelled out, so we will be left out with 1 plus X divided by P plus 1 plus X minus 1 divided by 1 plus P into E. Now taking the LCM and correspondingly the numerators, we will have, let's see, now the denominator would be to multiply them both. We'll get 1 plus P plus X plus P plus Px plus P square. And the numerator becomes 1 plus P plus X plus XP minus 1 minus X minus P. I hope you're following. Now the numerator, number of things cancel out. We see that 1 cancels out, X cancels out, and P cancels out as well. So we are now left with XP in the numerator divided by 1 plus X plus 2P plus XP plus P square into E. Let's take P out as a common term next. So we have V0 is equal to XP divided by 1 plus X plus P into 2 plus X plus P. Alright, so now the question says that we need to find out the value of P for a maximum value of V0. Now in order to find out the maximum value of V0, you must always think about finding the differentiation. So for maximum of V naught, dV naught, differentiation with respect to P should be equal to 0. So let's do that now in the next step. For this equation here, this expression here, let's find the differentiation with respect to P. We'll use U by V formula. Okay, so first let me write down the same equation here. We had V naught is equal to xp divided by 1 plus x plus p into p plus 2 plus x into E. Okay, so dV naught by dP with respect to P. Okay, so this would be, now in this case, let's assume that the value of E is unity, so it's 1. Now let's take the expression that is within the brackets alone and differentiate. Tongue twister there. Either way. Alright, so now let's apply U by V formula here. So recall the formula. We'll have to first differentiate. Let's see, now we have xp into derivative of the denominator, which is, since we are doing it in terms of p, we would have 2 plus x plus 2 p. Right? Okay. That's the denominator. Minus the denominator 1 plus x plus p square plus xp plus 2p into differentiation of the numerator, we would have just x whole divided by denominator square. Now since we have to equate this to 0, the denominator becomes 0 directly. Then all we have to do is equate the numerator. So the numerator now becomes xp into 2 plus x plus 2p is equal to 1 plus x plus p square plus xp plus 2p into x, taking that term to the other side. So this is what we have. Now we can cancel out x on both sides. 2p plus xp plus 2p square is equal to 1 plus x plus p square plus xp plus 2p. Okay, so this is what we have now. Let's see, can we cancel out anything else? We see that 2p can cancel out, xp cancels out. We are left with 2p square is equal to 1 plus x plus p square, which further gives us 1 plus x is equal to p square. Right? So now what is p? P is equal to root of 1 plus x. Well, I hope the steps are clear and the explanation is clear as well. And you will see that this answer matches option A. Root of 1 plus x. Well, this is the entire solution and I hope it has helped.